Greetings, fellow travelers of the cosmos. Today we embark on a thrilling journey into the heart of a universal phenomenon, running. Just as celestial bodies dance through the vast expanse of space, governed by the laws of physics, so too do runners navigate the track and field. Every stride, every leap, every burst of speed is a testament to the elegant principles that govern motion, energy, and force. Consider the awe-inspiring Usain Bolt, a man who seems to defy the limits of human potential. His seemingly effortless strides propel him to speeds that leave us breathless. But behind this extraordinary feat lies a fascinating interplay of physics principles. By understanding these fundamental laws, we can unlock the secrets to enhanced performance, whether our goal is to shatter world records or simply outrun our personal best. So, lace up your cosmic sneakers, and let's explore the fascinating world of physics on the track. Our journey begins with the profound insights of Sir Isaac Newton, whose laws of motion provide the bedrock for understanding the physics of running. Newton's first law of inertia tells us that an object at rest stays at rest, and an object in motion stays in motion at a constant speed and direction unless acted upon by an unbalanced force. This means that a runner at the starting line will remain at rest until a force, generated by their muscles pushing against the ground, propels them forward. Once in motion, the runner will continue at a constant speed and direction unless acted upon by other forces, such as air resistance or friction. Newton's second law of motion provides a mathematical framework for understanding the relationship between force, mass, and acceleration. This law states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. In simpler terms, the harder you push off the ground, force, the faster you accelerate, and the lighter you are, mass, the easier it is to accelerate. This explains why runners with less mass often have an advantage in sprints. Force is the engine that drives every stride. When a runner pushes off the ground, their muscles exert a force that propels them forward. This force has two components: vertical force and horizontal force. Vertical force is the force that counteracts gravity and keeps the runner from collapsing. It is generated by the muscles in the legs and feet as they push against the ground. Horizontal force is the force that propels the runner forward. It is generated by the horizontal component of the force applied to the ground. The greater the force a runner can generate, the faster they will accelerate and the higher they will jump. This is why strength training is so important for runners, as it helps to increase the force that their muscles can produce. Imagine a bowling ball rolling down the lane. It has momentum, a measure of its mass in motion. The faster it rolls, the harder it is to stop. Runners, too, possess momentum, and this principle plays a crucial role in their performance. Momentum is the product of an object's mass and velocity. A runner's momentum is a measure of how difficult it is to change their state of motion. A runner with a large momentum will be harder to stop or slow down than a runner with a smaller momentum. This explains why maintaining momentum is so important in running, especially over long distances. Every time a runner slows down or changes direction, they lose momentum, and it takes energy to regain it. Section 5. Energy, the fuel of champions. Just as stars radiate energy across the cosmos, runners harness energy to fuel their performance. Running requires energy to overcome inertia, air resistance, and friction. This energy comes from the food we eat, which is converted into chemical energy that our muscles can use. There are different types of energy involved in running, including kinetic energy, which is the energy of motion, potential energy, which is stored energy, and thermal energy, or heat energy. As a runner moves, their body constantly converts between these different forms of energy. Efficient runners are like well-oiled machines, minimizing energy waste and maximizing energy output. Understanding how our bodies use energy can help us train smarter and optimize our performance. Section 6. Stride rate and length, finding your rhythm. Running is a dance, a rhythmic interplay of stride rate and length. Stride rate, also known as cadence, is the number of steps a runner takes per minute. Stride length is the distance covered with each step. The optimal combination of stride rate and length varies depending on factors such as a runner's height, leg length, and running speed. In general, elite runners tend to have a higher stride rate and a longer stride length than recreational runners. Finding the right balance between stride rate and length is key to efficient running. By experimenting with different cadences and stride lengths, runners can find the sweet spot that maximizes their performance while minimizing energy expenditure. Section 7. The math behind the finish line. Mathematics, the language of the cosmos, can also be used to unlock the secrets of running performance. By analyzing data such as pace, heart rate, and stride length, runners can gain valuable insights into their strengths and weaknesses. For example, by tracking their pace over time, runners can monitor their progress and identify areas for improvement. Heart rate data can be used to determine training zones and prevent overtraining. And by analyzing their stride length, runners can identify inefficiencies in their form and work to correct them. There are now countless apps and wearable devices that can provide runners with detailed data about their performance. By embracing the power of data analysis, runners can make informed decisions about their training and optimize their performance. Section 8. Practical tips for cosmic runners. Ready to put this cosmic knowledge into practice? Here are some practical tips for runners of all levels. 1. Warm up properly. Just as a spaceship needs to fire its engines before launching into space, your muscles need to be properly warmed up before a run. This helps to prevent injuries and improve performance. 2. Focus on form. Good running form is crucial for efficiency and injury prevention. Keep your head up, your shoulders relaxed, and your arms swinging naturally at your sides. 3. Listen to your body. Your body is your own personal spaceship, and it will tell you when it needs rest or refueling. Pay attention to any aches or pains, and don't be afraid to take a break when you need it. 4. Make it fun. Running should be enjoyable. Explore new routes, run with friends, or listen to your favorite music to keep things interesting. Section 9. Run towards the stars. As we conclude our cosmic journey into the physics of running, remember that we are all capable of extraordinary feats. By understanding the fundamental laws that govern motion, energy, and force, we can unlock our full potential and achieve our running goals. Whether you're a seasoned marathoner or just starting out, embrace the joy of movement, the thrill of the challenge, and the wonder of the human body in motion. And as you lace up your shoes for your next run, remember that you are not just running on a track, but through the vast and awe-inspiring cosmos. So go forth, fellow runners, and may your strides be swift, your spirits high, and your journeys filled with the same sense of wonder and discovery that drives us to explore the universe around us.